In this video, we're going to be talking about some common if statement errors and implicit nesting. We're going to talk about errors doing some tracing problems, and tracing just means reading code and trying to figure out what it does. So if you'd like to follow along, go ahead and grab error 1, error 2, and error 3.c from the web course. Here's the first one. This is a code fragment, meaning it's not a full program, it's just some section of code. In this fragment, we're trying to determine if the user is allowed to go to some middle school camp. It's middle school, so they only accept people in 6th, 7th, and 8th grade. So we're going to ask the user what grade they're in, and then we're going to print out whether or not they can go to the camp based on that grade. So there's something wrong with this fragment. So we're going to put this fragment into a real program, a full program, and we'll run it to see if we can figure out what's going on. So this is error 1.c. Here's the fragment, and the rest of the code allows us to run it in the compiler. So we're going to build and run. We're going to try and see what's going on. So let's test first something that will give us a true answer. So a 7th grader should be allowed to go to a middle school camp. So that prints out correctly. If you're in 7th grade, you can go to the camp. So far, so good. Let's try it with a negative case, a known negative. Let's say a 4th grader is asking to go to the camp. We're going to put in, we're in 4th grade. And it's going to say, you can go to the camp, which is not something it's supposed to do. So we're going to try and read the code and figure out what's going on. So I'm going to try and trace through it real quick. Now we know that C is sequential, so we're going to start at the top of main. The first thing we see is this variable declaration. It's fine, it follows the syntax. It's got a data type, a name, and a semicolon, so that's okay. We have the print statement, prints out what grade are you in. We saw that running twice, it appears to be working. We're going to read in the user's grade. So right here, we should have a value. Now the one that wasn't working was 4, so let's assume grade is currently equal to 4. So now we need to evaluate this conditional expression. Now we have two relational operators. They're both less than or equal to. And since they're the same operator, then they are going to have the same level of precedence. So we're going to evaluate them in order from left to right. So the first thing we're going to do is look at this. This is 6 less than or equal to grade. So if grade is currently 4, we know that 6 is not less than or equal to that. So that's going to be false. But remember, since C doesn't have a Boolean type, false is represented by the integer 0. So what we're really saying here is that this evaluates to false, which is 0, and checking to see if 0 is less than or equal to 8. Now since 0 is less than or equal to 8, that's why we're printing out you can go to camp even when the grade is equal to 4. The problem we're going to have here is that regardless of what grade is, we're always going to print out you can go to the camp because our other Boolean option is 1. So regardless of what this evaluates to, it'll either be 0 or 1, both of which are less than or equal to 8. So this error is called compound expression error. We needed to use a compound Boolean expression, but we didn't. So here's the fix shown in bold. Instead of checking to see if 6 less than or equal to grade less than or equal to 8, we need to check it to see if 6 is less than or equal to grade and grade is less than or equal to 8. So if we put in that and symbol, that should fix things for us. So let's double check. We want 6 less than or equal to grade and grade less than or equal to 8. And now if we type in 4, it should correctly tell us that we're not old enough to go to the camp. We cannot go. All right, let's check out our next fragment. We'll go over here. This fragment says, if age is greater than or equal to 18, then set adult equal to 1 and vote equal to 1. Now this is a common mechanism called a Boolean flag. And if we had a Boolean type, we would normally use true and false instead. So in error 2, we have that fragment and a couple of other things. So a Boolean flag is typically set to a base value, either true or false, and then we change it when we're interested in seeing something different. So it triggers on a particular value. We're asking how old the user is, and what we'd like to do is that if they're an adult, we want to set these flags to true. It is true that they're an adult, and it's true that they're able to vote. And then, if they are able to vote, we want to print that you can vote. This is another cool thing that only works because of the way Boolean types are written in C. If vote is equal to 1, then vote is equal to true. And we can say, if true, print this. And if it's false, then it won't print that. So we want to take a look at that, and we want to see if we're allowed to vote in the election. So first we're going to try the known positive. If we're over the age of 18, then of course we get to go vote. And if we're under the age of 18, we should not be able to vote, but it's telling us that we can. So one of our if statements is having a problem. Now the problem is in the first if statement, the fragment that we've shown here. And it's based on the syntax for an if statement. If statements only have one statement inside them. So we can do if age is greater than or equal to 18. This statement is inside the if, but technically this one isn't, even though it's indented. So we're setting vote equal to 1 regardless of the result of the if statement. So if we want to fix that, if we want to encapsulate both of these statements, then we need to use braces. These curly braces or brackets allow us to group statements together and make both of them part of the if. So if we make that change to our source code, we encapsulate these two statements inside the if, then it should correctly tell us nothing if we're not old enough to vote. Now our next example does not look very different from the previous one. There's just one little modification that I'll show you. If we go here, this is a common error, and we put a semicolon after the conditional expression, let's see what happens. This is the case that we just fixed. Now we've broken it again. So it says we can vote in the election. So let's talk about what's happening here. Introducing a semicolon after the if statement introduces what's called an empty statement. So here's what's actually happening. This empty statement is the only thing inside the if, and these two bracketed statements are now not part of the if, so they get evaluated regardless. So we don't want to put any semicolons between the if and its contents. So the empty statement is syntactically correct. It just creates a situation where if the conditional expression is true, then nothing is executed. And there are reasons to use empty statements in your code. Here's an example of one that is working the way that it is intended. If age is less than 18, don't do anything, but otherwise set those two flags that we've been working with. And there's a lot of other ways that we can use empty statements to make our code run smoothly. In this particular case, there's a smoother way to do it. Okay, our final example is about a game rental program. And for simplicity's sake, we're going to assume that video games come in 3 ratings, everyone, teen, and adult. which of course doesn't match the ESRB, but it's only an example. And we're saying if they're over the age of 18, then they can rent adult games, and if not, they can rent games that are for everyone, and we'll later add in the teen print statement. So this is error 3. Here's our fragment copied over from the slide. The rest of the program allows us to run it. We're going to ask them how old they are and see what kind of statements we get. We're going to look for a couple of different things. The first is what happens if they're an adult. It says they can rent adult games. So far that's good. We want to print that if they're over the age of 18. Now if they're over the age of 13, but between 13 and 18, they shouldn't see anything because they can't rent adult games and they can't just rent games that are for everyone. So let's say a 14-year-old wants to rent some games. Our program is telling them that they can only rent games that are for everyone, which isn't true because they can rent teen games. So let's take a look at what might be happening there. We saw in some of our previous examples that the indentation that we assign to code doesn't necessarily mean anything. C in general does not see our white space. It ignores it. This isn't true for all programming languages. Python, for example, is very dependent on its indentation, but C is not. So this else, even though it's indented to line up with this if, is actually part of this if statement. So that if age is greater than or equal to 18, use this print statement, but if not, use this print statement. So this error is called matching else statements. If we want the else to belong to the first if, we need to separate it from the interior if. So we can use the curly brackets for that. We're going to say that this if statement here is part of this if, and this else is not. This else now belongs to this if. So that now if we tell it that we're 14, it doesn't tell us anything, which is the intended behavior for right now. Now we can go in and fix that. If they're over the age of 13 but not over the age of 18, then they can rent games from the teen category. And now everybody has a message. Okay, so that's our common errors, so keep an eye out for them as you're programming. We want to start looking at something called implicit nesting. So taking our game example, suppose that we wanted to add a category for 10 and up. How would we need to adjust those nested if statements in order to make that work? So we'll go back over to the code and make some modifications. We're starting with the smallest number on the outside, so we'll do that again. We'll say if they're over the age of 10, then check over the age of 13, then check over the age of 18, if they're between 10 and 13, they can rent games from the 10 plus category. We're not going to be very creative with that naming category. And then of course if that one's not true, if they're not over the age of 10, then they can only rent games from the everyone category. So we'll double check our cases here real quick, make sure that the modifications we made work. So we'll build and run, and we'll check an adult. They can rent adult games. We'll check a teenager. They can rent the teen games. We'll check the 10 plus category. They can rent from that category. And anybody under that can only rent games that are for everyone. So this is working as intended. But it looks kind of messy. If we wanted to add another category, we could. And we would just continue to nest these together, building in new levels each time. But it gets kind of messy to read with all of the indentation levels. So what we could do instead is called implicit nesting. And you'll also see this called if-else-if statements. And they work exactly the same. We'll check if a conditional expression is true, run statement 1, else check a new conditional expression. And if it's true, run statement 2. We can do as many of those as we need. And we'll have a final else statement to catch any extras, else a final run statement n. So the compiler treats this exactly the same as explicit nesting, which is what we saw in the example, but this format tends to look a little bit cleaner. It's a little bit easier for programmers to work with. So these sections are explicitly nested. We're not going to get rid of them in case we want to revisit them later. I'm going to comment them out, which means that they won't run. For example, if we were to run the program now, all of these lines that we have now commented are no longer run by the compiler, so they no longer exist as far as the compiler is concerned. But we'll leave them there so that we, the human readers, can take a look at it if we need to. And we'll look at the implicit nesting version. And we have to rearrange these a little bit because we want the first statement to catch the most constrained group. So if somebody's over the age of 18, they're also over the age of 10, they're also over the age of 13. So the message that is just for them is the one that we want to print first. And that way, if that one's not true, then we go on to check the next one. So if they're not over the age of 18, we'll say, okay, well, are they over the age of 13? And if so, they can rent the teen games. And if neither of those are true, we'll go, okay, well, are they over the age of 10? And if so, then they can rent from the 10 plus category. And then if none of those are true, we'll have this final else that says you can only rent games that are for everyone. And so both of these are the same. This one's an explicit nesting version, this one's an implicit nesting version, but they're going to behave exactly the same. And we can test it to double check. Here's our you can rent adult games. Here's our teenager. Here's our 10 category. And here's our default, you can only rent games that are everyone. So the output behavior is exactly the same in both versions, but this one tends to be a little bit cleaner, it's a little bit easier to read. The compiler treats both of them exactly the same, so there's no advantage to one over the other. You're free to use whichever one makes more sense to you. So if you're ready, go ahead and try it out. Here's a practice program to use implicit nesting. It outputs the response to a user's score in a game, so you can assume that you're provided with a score. You can either set an integer equal to that, or you can ask the user for the score, whichever you prefer, and print out a relevant output based on this table. In our next video, we'll finish up Chapter 7 with the switch statement, and I will see you then.